This is a video related to introduction to database. Of course, this is the second video for introduction to database. Okay, and let us discuss about few languages in DBMS. Languages are nothing but generally we use SQL. In SQL, we write queries in order to interact with our database, in order to perform operations with the data within the database. But when you look at SQL, there will be again some sub languages. For suppose one is DDL and another one is DML. So many other languages are also there, subparts. But for main thing, important, mainly used languages are DDL and DML. We define the database, we define the table, and then we will use the table. We will use the database. Excuse me. Now, for definition, one set of queries, and we call that one as DDL. And for other operations like insert, update, and delete, we will be using another language that is nothing but DML, data manipulation language. The first one is data definition language. So if you see data definition language, DBA will define the database, or the database designers will define the database. Sometimes a single person will do all the job. That is in case of small databases. When it is large or huge databases, then DBA and database designers will deal with DDL. And here there will be conceptual schema. In terms of conceptual schema, it will be. And in most of the DBMS, DDL is used for internal schema as well as external schema. We have levels in schema: internal or physical, conceptual, as well as external. Okay, so internal and external is also done by that. Those definitions can also be done by, can also be performed by DDL in most of the DBMS. In some DBMS, they gave a separate language. One they call that one as SDL, another one as VDL. Internal is SDL, external is VDL. Internal, the low level, physical level. So it talks about storage definition language. VDL, it is external. External is a view. It is not actual. It is a view. So view definition language. Okay. Then if you see data manipulation language, DML, there will be select query, update query, insert query, delete query, retrieval, and updates. Okay, and of course, there will be some DML commands, some sub-language that can be embedded into a normal programming language like COBOL, C, C++, as well as Java. Okay, there is a concept like that. DML commands are embedded in programming language, and they will provide library of functions, and those functions will perform the operations what the DML has to perform. Excuse me. So, for suppose if you take JDBC, there will be some classes. Within those classes, there will be some methods. Those methods are used to access the data within the DBMS. And of course, directly you can apply DML commands by using query language like SQL. You open Oracle SQL Star Plus and you type the query, and things will be done. So different ways does it. And if you see DML, there will be non-procedural as well as procedural language. Non-procedural means there will not be any procedure, directly a declarative. It is also called as declarative language. We will type one query, that's it, and it will perform the job. Okay, and what data to retrieve rather than how to retrieve. We will not bother about how we are retrieving. We will simply tell, I want these columns from this table. That's it, done. Okay, that is non-procedural as well as high level. Okay, and it can be standalone as well as it can be embedded in a programming language. Directly you can use, otherwise within a, by using we can embed that one in a programming language and then we can use it however you want to get. In low level there will be a processor you have to follow. In JDBC, for suppose when you are retrieving the data from database into your Java program, we will execute a query in the database. The database the DBMS will return a result to us, a table as a result. In a table, there will be multiple records. All the records at one shot, we cannot get into a program. So what we will do is we will retrieve record by record. Or there we will use loops as well as there will be positioning pointers. Okay, that's what the last point. You can embed that one in a, you have to embed that one in a programming language. Okay, so that is about types of DML. That is about the DBMS languages, DDL as well as DML, important languages. Okay, what we require, okay, as an EC student. And history of databases, if you see, earlier we used to use in database, otherwise to store data there were file systems, they were using file systems. Then a few database approaches has come. They call that one as relational databases. Afterwards, an important concept in a database has evolved, that is nothing but relational database. And after that relational database also, few other databases, they came with a few concepts in a database approach. Okay, that is what this slide talks about. During 1970s, there were pre-relational databases. For that, they used to use they used to get the distinct logical and physical data management. Logical in the sense outline, high level. Physical in the sense low level, actually how it is. Those kind of details they used to consider, and at that during those times, data management has become more important, and there is need of data models. Then in relational database systems in 1980s, so they concentrated on redundancy. They reduced the redundancy, no repetition of data in terms of storage, and there will be integrated data control. That is nothing but we can store data in different places in a distributed environment, and all those things controlled in a proper manner. And then multi-user operation, multiple users can access a database simultaneously with high performance. Those are the features evolved during the relational database systems in 1980s. Then in 1990s, few other databases approaches has come, that nothing but we can use object-oriented concepts in databases. So we call that one as object-oriented database. Then multi-dimensional databases, data warehouses, distributed databases. These are all came in 1990s. So in 1990s, we see object-oriented database. Here we store the data in the form of object, a real-time entity. Okay, and that object-related data will be maintained in multiple tables. Okay, one table customer, another table address, another table bank accounts, and in that each record is holding details about one object. In terms of object, that data will be considered as well as stored. Okay, so that is what object-oriented database. And multi-dimensional database. If you see multi-dimensional database, there will be multiple dimensions, otherwise multiple angles to look at the database in order to understand the data within the database in an appropriate manner. For that, the developer, otherwise the programmer or the database people, they have to look at the data in different angles to get the data in a more meaningful manner, more depth manner. So that's why they made dimensions here. So that is what multi-dimensional. Okay, and here a data cube will be created. A data cube will be created. Using that cube, we can go into the dimension whichever it is required. Whichever is required into that dimension, they will move and they will find out as well as they will get the meaningful information from that data. Sometimes when you look at the table just like that, we cannot get some details. When you observe carefully in different dimensions, then only we can get the real details, really useful details from our from the data which is stored in the form of database within DBMS. Then distributed database, that's nothing but database will be stored in different locations. For suppose Indian Railway Reservation System. Okay, and all those three will be controlled as a single unit. Although those are at different places, all the three will work collectively. Okay, that is what a distributed database. Okay, for suppose if you take one company or organization, there will be manufacturing department, headquarters department, sales department. Okay, each one has their own database and their databases are interconnected. That's nothing but headquarters sometimes may require manufacturing details. Sales sometimes sales data sometimes may be required by headquarters, something like that. Okay, nowadays our latest databases are all with object-oriented features, distributed feature. Most of the databases are like that. Okay, then one more concept, that nothing but database system versus file system. That's nothing but earlier we used to use file system to store the data, but there are a lot of disadvantages in maintaining data in terms of a file. Okay, so a lot of redundancy will be there, and lot of programs has to be maintained, and if there is any change in the structure of data, then program has to be changed. Like that, so many disadvantages are there. Okay, so many programs has to be maintained, and so many files has to be maintained in order to store the data. But in database, it is not like that. So let us look into that file system concept. So there are drawbacks when you store data in the form of a file in the file system. So what are those drawbacks? Extensive programming is required. Means what? More program you are supposed to write when you consider database and file system. For database, small amount of coding is sufficient. Very easily we can perform the operations. But when you store the data in a file system, then it requires more programming, more code, more operations to be done by the program. Okay, because it is not organized in a standard format. That's why everything should be taken care by program. So extensive programming is required, and ad hoc queries, the queries which will not come all the time, but sometimes whenever it is necessary, at that time we will use a few queries. For those queries, in order to make a query to the, otherwise in order to get the details for ad hoc queries, in order to get the data from the database for ad hoc queries, it is highly impossible. Okay, and then in file system, each file should have its own file management system. Okay, with file structure, and after that add the data into it, delete from it, modify it, and list of contents. There's nothing but for each file there should be a separate or its own file management system is required. Okay, that is also one drawback. And then when there is a change in the structure of file, then program has to be changed. So there is dependency on the structure. So you have to change the program based upon the structure. So program and structure of the file both are dependent to each other. When there is a change in the data type of a field, again the program has to be changed. The program which accesses the data again should be changed. That's nothing but data dependency. There is a structural dependency as well as data dependency when you store data in a file system. Those are some of the drawbacks. And if you see further, then there will be data redundancy in file system, and because of that there will be inconsistency. Same data without our knowledge otherwise unknowingly can be maintained in separate places as different copies. Those many copies are not required in database. Only one copy is sufficient. That will be used by everybody. Okay, so that is what redundancy means. Same content in different places. Okay, duplications. Okay, then difficulty in accessing data. Yes, it is very difficult to access data when you store the data in the form of a file system within the file system. Okay, and there will be data isolation also. There is also one more drawback, and because there will be multiple files as well as multiple formats. Because of that, some of the data will be isolated, and then some integrity problems. There's nothing but if you want to check, if you want to provide a rule, you have to write that one in a program. But in database, it is not like that. While defining the database, while defining the table, you can put one constraint, that's it, done. No need of any programming knowledge. So by while defining the table itself, you can put one single keyword by the side of one column, that's it. That particular constraint will be applied to the column. For suppose roll number should not be repeated. That can be taken care by some of the constraints in database. That features are not available in file system. So you have to write that but in a program. So integrity problems may come. Okay, if you want to add a new constraint, again change everything. Okay, something like that. So those are about database versus file system, database system versus file system. And whatever we discussed till now, those points only will come over here. Okay, why we use DBMS, why we are not using file system, what are the drawbacks in the file system, and what are the benefits in the file system, in the DBMS system. In DBMS system, okay, database consists of logically related data stored in a single repository. At one place, everything can be stored as a single repository. And some other advantages are like inconsistency will be removed, anomaly will be removed, dependency will be removed, structural dependency as well as data dependency, both will be removed in DBMS. And it stores data structures, it stores relationships as well as it stores access paths. And then there will be some data structures, relationships, and okay, that's what. So the point here is we are using, we have to use DBMS. We should not use file system, because in file system, when you store data by using only the file system, then there are so many drawbacks. Okay, and in DBMS, all those drawbacks are eliminated. Okay, so that's why we use DBMS. That's why we are not using file system directly. And then the last concept in the first unit, that's nothing but overall database structure. Overall database structure. So whatever we discussed till now, everything, almost everything is present in this diagram. So this is one of the important diagram in order to understand what is database and what is DBMS. That's what the concept here. Okay, and let us come from the starting onwards. At the top, it is like this: naive users, application programmers, sophisticated users, database administrator. We talked about all these types of users. These are all different types of users. What we studied is database administrator will do the maintenance related things about our database. First of all, they will create the database. Sometimes they may create the tables within the database, and they will give that one to the database designers. Otherwise, database designers and the database administrator will look about that database creation and structure. Once it is done, it will be given to the end users. In end users, there are different categories. One is sophisticated users, complex operations they will do. Directly, they will interact with the database. Directly, they will provide the queries. Okay, and some other end users are application programs. That's nothing but developers. They will develop some applications. Again, those applications within their code, they will access the database. Likewise, also few users will use DBMS. Means what? As an end user, we use an application. That application might have developed by a programmer or a developer. That developer wrote a code in their program, and that code will interact with the DBMS. That's what the concept here. So that is what application program. So application programmers write application programs. Sophisticated users or analysts use query tools. Directly they will write queries, otherwise some tools they will use, and they will interact with the database. And database administrator will use administration tools and perform some administration tasks. Okay, for suppose definition of the database, creation of users, maintenance of the storage, all those things done by database administrators. When you look at the top left corner, naive users. Okay, these are the real end users. For example, bank tellers, agents, as well as web users. Web users, we are the web users. If you access Gmail, you are the web user. Okay, so they use application interfaces. Means what, they use an application. That application in turn will access the database. That's what the point. So naive users use application interfaces. Application programs write. Application programmers write application programs. Sophisticated complex analysts use query tools, and administrator will use administration tools, and by using these things they will interact with the database. And when you look at the database, DBMS, when you look at the DBMS, there are two categories. One is query processor, another one is storage manager. If you look at this diagram carefully, there are two boxes in the middle. One box is query processor, right hand side it is written, and another one is storage processor. Another one is storage processor. Okay, and below that it is hard disk. Within the hard disk, our data will be stored in the form of a file. Otherwise, within the file system only it will be stored. Okay, but before storing the data in the form of a file or in the form of or within the hard disk in a file system, in the middle of the user as well as this storage, the DBMS plays a major role. Okay, raw data will be stored in the hard disk within the file system of the hard disk. Okay, it is for sure, but we are not directly using the file system. In the middle, DBMS has come. Database approach has come. In that DBMS will store the data in the organized fashion in terms of tables, rows, columns with constraints and all those things. Within the it will store, it will maintain everything within the disk storage. Within the disk storage. Of course, within the disk storage, there will be some data about data, metadata or data dictionary, as well as some statistical data, and there will be some indices, index concept. Okay, so many like that. Okay, so let us look at these points. Now the first one. So the functional components are two: storage manager as well as query processor. The last one is just simply storing the data in the form within that storage device. That's it. We will store in the form of data. There will be some data related to data dictionary, metadata, and there will be some statistical data, and there will be some indices. Everything will be maintained in storage space. Okay. So by main part are storage manager and query processor. That is one. Storage manager is one component, and query processor is another. And when you look at storage manager, see here, large amount of data has to be stored in the disk in an organized fashion with all the concepts like data structures and so many things are there. So how to store, where to store, which data structure should be used, everything will be taken care by storage manager. And when we come to query processor, it will take the query and it will process it. It will see, however the user interacts with the DBMS, from everybody a query will be generated. So from application program, query will come. From application interface, query will come. From database administrator, administration tools, query will come. Query tools, query will come. Everywhere, query will be there. A question: what to be performed for that particular user? Different means are there. They will interact with the DBMS in different means, thus in different ways. So, query processor will take that query, it will process it as a normally conceptually we can understand it. Look at the point here. Sub point helps the database system simplify and facilitate access to data. It will simplify the things. It will take the query and it will perform the operations. Otherwise, it will tell what to be performed. It will tell what to be performed. Okay, and that will be performed in the lower level. Okay, so what is the job of database system? So it translate updates and queries. It translates the updates. If there is any update, that update as well as the queries written in non-procedural language at the logical level into an efficient sequence of operations at the physical. In the physical level, an operation to be performed. That operation, how it has to be performed is not given, but what they want, they will give in the query. In the query, they will specify what they want to perform. So that thing will be converted, which is written in the logical level, otherwise high level, into the low level operations. Low level is nothing but the physical storage level operations, sequence of operations at the physical level. That is taken care by database system. Okay, then if you look at this is all these slides are related to overall database structure. So when you talk about query processor, it consists DDL interpreter, DML compiler. Okay, let us look at this diagram once again. So when you look at the query processor, see the first one is DDL interpreter. DDL means data definition language interpreter. The other one is DML query. A query will come from the in terms of DML. That query will be compiled by DML compiler and organizer, and then it will be given to query evaluation engine. Okay, so you have to look at query processor, the middle one. In the query processor, DML queries, DML compiler, and query evaluation engine. And if you look at the application programs over there, compiler and linker. But nothing but it is a program. So that program will be compiled and linked, and it will be given to application program object code, and then again it will go to query evaluation engine. That's nothing but query evaluation engine will take care about evaluating. Otherwise, okay, we will look at all those points. So remember these things: DDL interpreter, DML query, DML compiler, query evaluation engine, and remaining things are all normal. They will be compiled, linked, and then application program object code. Those are all normal things. We know all those things. If you know C language, we can understand those points. Now, those three has come here. First one is DDL interpreter. DDL interpreter, what it will do? Interpreter, compiler are similar softwares. What they will do? They will convert from one language to other language. Of course, the compiler simply converts, but whereas interpreter, it will convert and execute. Okay, so there is DDL interpreter in query processor, and DDL instructions will be coming from administration tools which are used by DBA, database administrator. Okay, so here it receives DDL statements, data definition language statements. Those statements will be interpreted by DDL interpreter, convert and execute. So it will do conversion. Okay, and then records the definition in the data dictionary. So we are providing definition of the database of the table by using DDL. Okay, so that will be stored in data dictionary. In the disk storage. Within the disk storage, we have data dictionary also. So let us look at that point. If you carefully observe the last one, disk storage in the cylinder, it is showing data dictionary. It is showing data dictionary. Okay, and statistical data indices are also there, but data dictionary, it is from that DDL interpreter. It will come from the DDL interpreter. I think in this diagram it is not given properly, so I'll check that. Okay, but main point here is that DDL statements will be interpreted by DDL interpreter, and it will put that one in a data dictionary within disk storage. That is the job of DDL interpreter. And the other one is DML compiler. DML compiler, what it will do? Again, it will convert. Okay, that's nothing but translation. What is the translation? Translates DML statements into a query language, in a query language, into an evaluation. A query will be taken. That query is nothing but a DML query: update, select, insert, delete, some such kind of query. That query will be converted into an evaluation plan. That is nothing but low-level instructions. A query will be converted into instructions. That to low-level instructions. Okay, and that the query evaluation engine understands. So below that DML compiler, there is one more block, that's nothing but query evaluation engine. So query evaluation engine will take that query, and process that particular query. But in the middle of that, what is that DML compiler? What it will do? It will translate the query into an instruction which is understandable by query evaluation engine. That's the job of DML compiler. And if you look at the second point in DML compiler, of course, that conversion will be in different evaluation plans. Okay, plan A, plan B, plan C, plan D, like the different plans it will be, different types of plans it will, different several number of alternative plans it will. Out of that, it will take the best of it. So that is what the third point here. The third point is telling like this: DML, a query can usually translate it into several number of alternative evaluation plans. Okay, not only one plan, it will be in different plans. How to evaluate this one? How to evaluate this one? The one plan will be there, and not only one plan, multiple plans it will take. Out of that, it optimizes. So DML compiler also performs query optimization. What it will do? It picks the lowest cost. It picks the lowest cost evaluation plan from all the alternatives. There are so many alternatives. Out of all those alternatives, it will take the best one with the lowest cost. Means what? Which performs fast, which requires low resources, something like that. Low cost. Okay. So that is the job of DML compiler. It translates into an alternative evaluation plan, and it picks one evaluation plan for optimization purpose. And last one is query evaluation engine. What it will do? It executes those which are generated by DML compiler. DML compiler translated and gave an action plan what to be done to query evaluation engine. Now the query evaluation engine will execute it. Okay. Then storage manager. The first one is query processor, and the second one is storage manager. In by the name itself, we can understand it manages the storage, because there is large amount of storage disk space that should be managed properly. We cannot simply store just like that. So what they are doing? Storage manager, it is a program module that provides interface. Okay, it acts in between low-level data stored in the database. That's nothing but physically how it is stored. That is low-level data, and application programs or the queries submitted to the system. Okay, so user will interact with the DBMS by providing some query by different means. Okay, for that one and the actual physical storage, in the middle of those two, storage manager will perform some operations. What are those? Of course, it is responsible for interacting with the file manager also. File manager will look after files, how the file should be stored, where it is stored, how much space it is allocated, all those things will be taken care by file manager. Of course, it is responsible to interact with the file manager also, which one storage manager. And if you see the third point, raw data stored on the disk using the file system. So in the cylinder at the bottom there is a cylinder. Within that cylinder, raw data will be stored. Simply will store the data. Some raw data in the form of zeros and ones, binary format. We will store the data. Okay, and over there we will use file system for storage purpose. At the end, file system is used. But we are not only using file system. That file system is used only to store the data, but that data is organized in the higher level in terms of tables, rows, and columns. Okay, so generally that file system and storage files in the file system, everything will be taken care by operating system. That's what that point tells, which is usually provided by a conventional operating system. Then what is the job of storage manager? Translates various DMS statements into low-level file system commands. Okay, so many statements are there in DML queries. For suppose we have given an insert query. Now that insert query will go through DML compiler, then query evaluation engine, and then it has to be perform some operations in the file system. So that will be taken care of by storage manager. It translates that particular query, what to be done, and it will perform those things, and it will give that one in the form of a file system command. That's nothing but operating system has few commands. If this is the command, it will perform this. For suppose in C language, you might have seen open, read, write, append, and then close. Those are the operations with the file. So those are the commands in the file system to operate the files in the file system. Those are provided by the operating system, in fact. Okay, those are provided by the operating system. So those are the file system commands. So into those file system commands, our DML commands has to be converted. That is taken care by storage manager. Okay, so what happens? Last point: storage manager is responsible for storing as well as retrieving as well as update data in the database at the low level, at the storage level. Okay, and then it also includes few components. Storage manager. There's nothing but authorization and integrity manager. We have studied this one. Authorization means there is data. That data is given access to only few users, not all the users. Giving access is nothing but authorized. Not giving access is nothing but unauthorized. That thing can be taken care by storage manager. Even integrity manager also. Integrity manager in the sense there will be some constraints. We have to apply those constraints whenever the user is giving data or manipulating the data. Okay, for suppose phone number only, it should be only number 10 digits. For that you can write a constraint. If the user is not following that constraint, then database will not allow the user to perform modifications. Okay, so that will be taken care again by the storage manager. And then transaction manager. Transaction is nothing but series of operations related to one job, one main job. Okay, that complete definition I will give in the next slide. Now, if you see transaction manager, during the transactions we have to maintain consistency, and there should not be any conflicts. Okay, consistency in the sense, possible those are series of operations. Sometimes because of failure in the middle, that the transaction may maybe it may be stopped. Okay. Now, when in the middle of the transaction, if it is stopped, if it is failed, then the transaction completely it has to. We have to stop that transaction completely. Means what? Some operations are performed; those operations should be reversed back. Okay, so that is what you have to do that one in order to maintain the consistency of the data. So that will be taken care by transaction manager. Okay, let us read that point. Transaction manager. So it is part of storage manager. What it will do, it ensures that the database remains in a consistent state, correct state, even in the middle of failures. Okay, and that concurrent transaction execution proceed without conflict. There should not be any conflicts because there will be concurrent access by multiple users. And when the transaction is going on, it is not only one operation. There can be 10 operations, sub operations within a transaction. Now, when you are performing those 10 operations, somebody else may also perform those kind of operations on the same data. So there should not be any conflicts. So it has to be taken care. So that will be taken care by transaction manager and the storage manager. Then file manager, what it will do, it will allocate the disk space, and it will take care about data structures used to represent. Data structures are nothing but it is the way how we store the data in a disk. Okay, so those things will be taken care by file manager. And then buffer manager. Buffer in the sense we are performing one operation. For that operation, we require one data that has to come from disk. So in the middle of the disk and the program, we can make a buffer of storage. Or there we can put the data for a temporary purpose. So that is what responsible for fetching data from disk storage into main memory. That's nothing but main memory is nothing but RAM. So whenever you are executing any program, the code of the program should be loaded into RAM. Then only you can execute that program. Otherwise, you cannot execute that program. Okay. So similarly, if you operate any data from the database, that should be loaded in the main memory. So we will be fetching the data from disk to main memory. So for that operation, buffer manager will be used, and it will decide which data to be placed in the main memory. And buffer manager is a critical part of the database system since it enables the database to handle. There's nothing but it handles large amount of data, which is whose size is more than the main memory. For suppose RAM size is 1 GB, but you are trying to fetch the data which is more than 1 GB. At the time, buffer manager plays a major role. Okay, it will take care about how to fetch the data and how to manipulate that particular data. Finally, transaction manager. So this transaction manager is nothing but it looks after transactions. What is a transaction? As I was telling, transaction is collection of operations that performs a single logical function. That's what the point here. Single logical function. For suppose I want to get the money from bank. If you want to get the money from bank, so many operations has to be performed. You have to open your account. You have to opening your account. You have to open your account in, for suppose, net banking, or you have to put your ATM card in ATM machine and type in and select the amount. Those are a list of operations, collection of operations to perform one single logical operation to draw the amount, something like that. Okay. Now, each transaction should maintain atomicity and consistency. Consistency in the sense correct. After the transaction and before the transaction, the database should be in a correct state. It should not be in an incorrect state. That is what consistency. Okay, because series of operations, and multiple users are performing again a series of operations, and multiple users are using the same database, then there is a possibility of inconsistency in the database. So transaction processing has to take care about all this. So transaction manager will take care about that. Okay, so atomicity in the sense, if you are doing any transaction, for suppose the transaction requires 10 sub operations, those 10 sub operations has to be performed. That's it. Otherwise, those 10 operations should not be performed. That is what atomicity. Okay, perform everything, otherwise perform nothing. That is what atomicity. And consistency. Okay, so transaction should be like that. So we require that transaction do not violate any database consistency constraints. So when you are performing the transactions, it should not violate those constraints, atomicity as well as consistency. So if the database was consistent when a transaction is started, then the database must be consistent after the transaction successfully terminates. Before the transaction, the state of database should be consistent. After the transaction, the state of the database should be again consistent. We have to maintain that. Okay. So all these things will be taken care by transaction management, that atomicity, consistency, okay, all those things. And so that is what last point. Um, Transaction manager ensures that the database remains in a consistent state despite system failures. So even though there are system failures like power failures or operating system crashes or transaction failures, any any problem comes, you have to maintain your database in a consistent state. So that will be taken care by transaction. Okay. So that is all about database, introduction to database and overall database structure.